Hi, good morning. Today our learning standard is explain the characteristics of identity matrix. Identity matrix is the most important part in the topic of matrices. So let us focus and try to grab the concept of identity matrix. Okay, what is identity matrix? Okay, in maths, getting the same answer as the original number is identity, is the meaning of identity. So let me give you a few examples. So what multiply with 3, you'll get the same answer as 3. And what if 3 multiply with what number, that you will get the same answer with 3. So of course the number is 1. 1 times 3 is 3, you get the same number. 3 times 1 is 3, you get back the same number. So 1 is the multiplicative identity, multiplicative identity. So in matrix, identity matrix, what does it mean? Identity matrix, that means this identity matrix, when you times with a matrix, you'll get the same matrix. So now how do you get identity matrix in the matrix? So you cannot just 1 here you times with something. Let's say 1 2 3 4. You cannot multiply this one, you cannot multiply, because the order is different. This is 1 by 1, this is 2 by 2. These two matrices cannot be multiplied. So now you have to think, what is identity matrix in matrix? Okay, first it must be, if your matrix is, the order is 2 by 2, your matrix is 2 by 2, your identity matrix must also be 2 by 2, so that you'll get the answer the same as this one, M, 2 by 2, right? You cannot have identity matrix 3 by 2, even though it has the same column and row, because after that what you'll get? You'll get matrix 3 by 2. 3 by 2 is not the original matrix. Do you get that? Okay, now let's see the characteristics of identity matrix. So you know the concept that if identity matrix you times with a matrix, you'll get the same matrix, right? So if this one is 2 by 2, you'll get a 2 by 2 matrix, the same elements, and your identity matrix must be also 2 by 2, 2 by 2. So the first characteristics of identity matrix, it is a square matrix. It cannot be 3 by 2, no, cannot. It must be square, 3 by 3, 4 by 4, depends on your original matrix. Okay, so this is the first characteristic. The second one, what do you put the element here? What should be the element? What numbers should it be? Should it be all 1? What are the elements, the 4 elements here? Okay, let's see one example. Let's say this is your identity matrix and you want to times with 1, 2, 3, 4. And you should get 1, 2, 3, 4 also, right? Okay, so for you to get, you know that this one, the first row here will multiply with the second column, you'll get 1. Okay, you'll get 1. So what you put here? You get back this 1 here, this one. So if I put 1 here, what will happen? 1 times 1, yeah, 1 times 1 plus this one, you want it to become 0, right? So if I put 0 over there, so plus 0, you'll get 1. So you get this one, right? So I put 1, 0. Okay, let's continue with this one. You times with the second column. What do you get? You'll get 1 times 2 plus 0 times 4 is 0. You'll get 2. Yes, you get 2. It seems that it is the first 2 elements already the same, right? Already the same. Okay, we try again for the next elements. Yeah, for the next elements, I use white color is better. 1, 0, and then what if I try, you want to times it with, you want to get back the 3. So here, this one you have settled, you have settled the first row. Now we go to second row. So you want to get back 3 here. Yeah, 1, 2, you got it already. How to get back 3? 1 times 1, if you still use 1, 1, 0, what you'll get? 1 times 1, 1 plus 3, you get 1 here, right? So cannot, this one cannot. It cannot be 1, 0. Cannot be 1, 0. So, can we try 0, 1? Yeah, 0, 1. So, 0, you see, 0 times 1 is 0. Okay. 0 times 1 is 0. And then 1 times 3 is 3 plus 3. So, you get 3. Wow, you get 3 here. Yeah, we are very close already. So, the next one is this row will times with this. Just now we have done this one. Okay, see, 0, 0 times 2, you'll get 0 plus 1 times 4, you'll get 4. You get 4, students, you get 4. So, you get back the same matrix. Do you see that? You get back the same matrix. So, the identity matrix for the matrix that you get the same answer with the original matrix when you multiply is 1, 0, 0, 1. Okay? So we will try again. We will try identity matrix. One of the characteristics is vice versa. Yeah. What if this number we multiply with this identity matrix? Do you get the same answer? Okay. Okay, now we know that this identity matrix, 1, 0, 0, 1, when you multiply with 1, 2, 3, 4, you'll get the same matrix 1, 2, 3, 4. Okay. In other words, in short, you know that identity matrix, when you multiply with a matrix, let's say matrix A, you'll get matrix A. But now we want to check, yeah, we want to check whether if matrix A we multiply with I, the matrix identity, do we still get the matrix A? Yeah, that one we want to check, because identity meaning if 1 times 3 you get 3, 3 times 1 you also get 3, right? Yeah, like 1 when you times with any number you'll get, let's say A, you'll get A. Yeah, A when you times with 1 you'll get A also. Yeah, A also. But in matrix it's very different. If matrix A you multiply with matrix B, you will not get the same answer as matrix B you multiply with matrix A. You will not get the same answer. So now we want to check. We want to check what if we change, we switch. We start with matrix A first. Yeah, matrix A first. 1, 2, 3, 4. We multiply with the 1, 0, 0, 1, the matrix identity. So what do we get? So first thing is, you start with row. The first row you multiply with the first column. Yeah, when you multiply that, what do you get is 1. Yeah, 1 times 1 is 1 plus 2 times 0 is 0. So the answer is 1. Okay, so the next one, this first row, now you multiply with the second column. With the second column, what do you get? Okay, what do you get? 1 times 0 is 0 plus 2 times 1 is 2. So 0 plus 2 you'll get 2. Wow, we are very close to the same matrix. Okay, now we try the second row. We multiply with the second row, this one. This one, second row, multiply with the first column. Yeah, with the first column you should get the answer here, right? Okay, we write it here. So what is it? 3. Yeah, you see, 3 times 1 is 3 plus 4 times 0 is 0. So 3 plus 0 is 3. Yes, that is the same. The third element is the same. So now we go to still with the second row, but this time you times with the second column. So what do you get? Your answer here, 3 times 0 is 0 plus 4 times 1 is 4. Yes, we get here 4. So we get the same matrix. This is true, and this one also true. Yeah, it's right. So we can make a conclusion here that the identity matrix for 2 by 2 is 1, 0, 0, 1. Yeah, for the 2 by 2 matrix. What about the identity matrix for 3 by 3? Can you guess? Okay, of course you have 3 elements here. Start with 1. And then here 0, 1, 0, 0, 0, 1. Yeah, this is the identity matrix. Actually, very easy to understand. You must start with the 1 here. Yeah. Here, the diagonal, the main diagonal. Yeah. Here. And the rest is 0. Yeah. Okay, now we can conclude that matrix identity in a form of this one, 1 0 0 1 or 1 0 0 0 1 0 0 0 1 when multiplied with matrix A will result in matrix A. That is this one. Yeah, it's vice versa, you still can get A. Yeah, identity matrix you multiply with one matrix A, or matrix A you multiply with identity matrix, you'll still get A. Yeah, and the elements in the identity matrix consist of only 0 and 1. You can see here only 0 and 1, but there is a special character, that is element 1 placed along the diagonal. Yeah, this is diagonal, from the top left corner. Top left corner is this one, left, to the bottom right corner, bottom right, and the other elements are 0. Yeah, but from the left, from the left here, okay, to the bottom right must be 1. Yeah, that means here, yeah, this one. Okay, this is the diagonal, all will be 1 and diagonal, the rest will be 0. You can see here all 0. So it's very easy. Easy. There is a pattern over there, you can see. Okay, next, the matrix for this one is known as identity matrix and denoted as I. Yeah, when you want to denote your identity matrix, you always use I. Yeah, the I equal to this one, 1 0 0 1. So people will know that when you write I there, the meaning is identity matrix. Don't use any number. Other matrices you can write A equal something, 1 2 3 4, but you cannot write I equal 1 2 3 4. No, this is very special. I, the symbol I, only used for identity matrix. Okay, then identity matrix, what I have said just now, is always a square matrices, always square matrix. Yeah, identity matrix I, when multiplied with the matrix A, will result in matrix A. So you can write like this. This is the formula. Very important. Okay. At one example. Example 21, write the identity matrix based on the order given below. So one by one, the identity matrix will be 1, only 1, no 0, because this is 1 row, 1 column. This is 1 by 1. This is the identity matrix. For B, this is for A. For B, 2 by 2, that is what we have been doing, 1 0 0 1. This is a 2 by 2 identity matrix. So C, 4 by 4, of course, I give you time to let you pause this video. Can you do it? I give you 3 seconds. Okay, of course, you'll start with 1 0 0 0, because 4 by 4, right? 0 1 0 0 0 0 1 0 0 0 0 1. So this is a 4 by 4 identity matrix. Okay, 5 by 5. 5 by 5. Start with 1 0 0 0 0. 5 elements. So 0 1 0 0 0 0 1 0. Okay, 0 0 1 0 0, 0, 0, 0, 1. So this is a 5 by 5 order. So you can see, you can see the diagonal here, is always 1 and the rest is 0. So 4 by 4 you have 4 ones, 5 by 5 you have 5 ones. This is very simple. It has a pattern over there. So class, we look at example 3. Example 3, given that matrix S is this one, matrix S, and matrix T. Calculate S times the identity matrix plus T times the identity matrix. So you know your S, this one, 7, sorry. Your S is 7263. When you times with this one, I, identity matrix 1, 0, 1, 0, 0, 1, you'll get also 7263, right? You'll get back this one. So actually SI is equal S, and then TI is also equal T. So how do you solve this one? What you do is S you just plus with T, S you just plus with T, because SI is also S, TI is also T, because I is the matrix identity. So you just add 7263, you add with your T is 3, 1, negative 5, 4, so you do the job. It's very easy, we have done it before. Okay, for B, IS you times with T. Okay, you know that IS is actually S, so S you times with T. S times with T, that means your S is 7263. You times with your T, 3, 1, negative 5, 4. So you just do the normal calculation for matrix, you get the answer. I will not show to you. Okay. We have learned about identity matrix. So I hope you can understand. It helps you to understand better. You can always rewind this video and refer also your textbook, and I'm very sure you will conquer what is identity matrix. Next we'll do inverse matrix, and it has a connection with this identity matrix. So stay updated. You can always like and subscribe my channel. Okay, bye.